Another way through which we can perform decision trees is with the help of average disorder. So for any dimension, we partition the set of training examples into subsets. So the target is to create a number of subsets from the whole set. The whole set is basically the all the is the subset. The whole set is basically consisting of all the training examples. The number of subsets in is the number of values of the dimension. The examples in a subset has the same value for that dimension. For example, risk is a dimension and it can have three possible values. Risk can be higher, risk can be moderate, or we can also have low risk. So this has the effect of cutting the example space by hyperplanes. The dimension to be partitioned first is determined by the average disorder of the examples partition. So the purpose of calculating the average disorder is to determine the dimension that dimension needs to be partitioned first. So the space is partitioned sufficiently when all the training example in a partition have the same class or the category or the label. For classification of instances whose class label is undetermined, we simply place it in our concept space and note the label of the partition which encloses it. So now let's consider an example. So it's basically the same example, but this time we are trying to make decision trees through average disorders. So we have the same number of individuals with the same attributes, and here we have our resultant output class. This time we need to calculate the average disorder, and here is the equation through which we can calculate the average disorder, and it says that we need to calculate the summation of NB with a division of NT, and this needs to be multiplied with a summation of minus NBC divided by NB, and we are taking the log base 2 of NBC divided by NB. Now let's see that what these variables means here. Here NB is the number of samples in branch B, and T is the total number of samples in all of these branches, and NBC is the total samples in branch B of class C. That's why we are saying it as NBC, because it is the total samples in branch B for the class C. So if we look for the attribute name here, we will see that this attribute can have three possible values, right? You can confirm this from the data set that the attribute with the name here can have three possible values. It can either be blonde, it can either be brown, or it can be red. And you will see in the data set that the total number of occurrences for blonde are 4, right? So there are 4 individuals which have hair color blonde, there are 3 individuals which have hair color brown, and there is only 1 individual which have red hair color. So on the basis of these attributes values and attributes occurrences, we can calculate our average disorder. So first we will calculate for blonde, then for brown, and then for red. So for blonde it will comes out to be 4 by 8 because there are 4 occurrences out of 8, and then we can use the same equation which we seen in previous slide, and we can put the corresponding values, and we will see that for the case of blonde it will comes out to be 0.5. Similarly, for the case of brown this comes out to be 0, and for the case of red it also comes out to be 0. So with these 3 values we can calculate the average disorder for this specific hair, which are blonde plus brown plus red. So if we combine all these 3, this will comes out to be 0.5, and hence we know that the average disorder for this particular hair attribute is 0.5. Similarly, the way through which we have calculated the average disorder for hair, we also need to calculate average disorder for height, we need to calculate average disorder for weight, and we also need to calculate average disorder for lotion. And all these average disorders will come out to be 0.5, then for height it is 0.6886, and for weight it is 0.9386, and for lotion it is 0.6067. Now most homogeneous attribute is here, so put here as the first test. Now we from these results we can see that the homogeneous attribute is resulting to be here, so we need to start with the hair, and we can make our tree with the base of hair, and it has three possible values which are blonde, red and brown. Now with red and brown hair color, all the training set is completely satisfied, right? Because we have also seen this in the previous example that with red and brown hair color the training set is satisfied. So the only problem which we face here is with the blonde hair, because in the blonde hair the guys, the people with blonde hair can either be sunburn or not sunburn. So in this case we will need to have another attribute, and the second attribute here is with height, and we are looking height with hair is equals to blonde, right? So we will see that the guys which are tall and have hair blonde are 1, for average it is also 1, and for short we have 2 possible occurrences, right? So now we need to make or calculate the average disorder for all these attribute values, and the procedure for calculating the average disorder is the same. For tall it will comes out to be 0, for average it comes out to be 0, and for short it is 0.5. And in order to calculate the total average disorder we need to add all of these, and you will see that the total average disorder comes out to be 0.5. Similarly, for other attributes but with hair is equals to blonde, the average disorder is 0.5, and the average disorder with hair is equals to blonde is 1 with the weight attribute, and with hair is equals to blonde with the lotion attribute it comes out to be 0. In this way, for all with the specific hair is equals to blonde hair type, we are calculating the average disorder with the other attributes. And in this way you can see that the lotion is with the minimum average disorder, so it will be the next test, so we can use lotion with the hair here. So we can use these two attributes to make the final outcome for these specific individuals. And you will see that these were the simplified cases, but these complex cases we solved with this additional attribute. So if we talk about the rule extraction process, then we can create these rules on the basis of the tree which we just formed. We can say that if the person's hair color is blonde, then the person uses lotion, and then there is no sunburn. On the other hand, if the person's hair color is blonde, the person uses no lotion, then person turn out to be red in that case. The rest of the rules can be, if the person's hair color is red, then person turns out to be red, and if the person's hair color is brown, then there is no sunburn. So this was the two basic ways through which we can form our trees, and we can extract rules, and then we can perform pruning of those rules. Sometimes in evaluating the decision trees becomes we face two major problems. One is bad data and one is missing data. So bad data means that if one set of attributes has two different outcomes. So in this case, we will say that we have some bad data in our data set. On the other hand, the data will be missing if an attribute is not present, perhaps because it was too expensive to obtain. So in this case, where we don't have some attributes present in the data set, we can say that we have missing values in the data set.